Now let us solve one question on 1, 1 and on 2 functions. This is a simple question from nest 20, second shift question 8. Let's read it. Let f be from R to R a function defined by f of x equal to mod of x plus 2x for x in the set of real numbers. Then f is 1 to 1 but not onto, invertible, and f inverse of x is negative mod x plus x by 2 for x in R, onto but not 1 to 1, invertible, and f inverse of x is equal to negative mod x by 3 plus 2x by 3 for x in the set of real numbers. Now this is a multiple choice question, so only one option is going to be right. Okay, what do you think we can do to solve this problem? Tell me, any suggestions?
I think we can use the modulus property over here to create two functions wherein how the function will behave when it's less than 0 and how the function will behave when it's greater than 0.
Very good, very good. So I can say that f of x is equal to x plus 2x or 3x when x is greater than or equal to 0, and f of x is equal to negative x plus 2x, negative x plus 2x, that is x when x is less than 0. Raise your hands if you understand how this result came. Okay, now what? It's pretty simple now. Both these graphs, okay, both these graphs, f of x equal to 3x and f of x equal to x, they represent lines. Both are lines, but these are not lines occupying the whole x-axis. Meaning, for the red part, I will draw it only in the first quadrant. Okay, it's y equal to 3x, so the angle is greater than 45 degrees. Let me show it here. And then x, so y equal to x for negative values of x, something like this. Okay, so this is our graph of the function. First of all, observe that this graph is defined, well, the function is defined for all values of x, there is no question about it. Do you think that our function is 1 1? If yes, why is it 1 1?
Yes, sir.
It is 1 1. Okay, why do you think it is 1 1?
Because for individual values, for all of us the real, we have unique outputs.
Okay, fine. So the function is 1 to 1. Okay, the function is 1 to 1. For the same value of y, there are no different values of x. So it's 1 to 1. Everybody agrees to this?
Yeah.
Okay, so the function is 1. Is this function onto?
Yes.
We read that yesterday. If we project our graph on y-axis, we will get the range of the function. But if you project this entirely, then all of the negative part, y part will get covered. And if you project the red graph, then all of the positive part will also get covered. So it is also onto. Okay, and because it is both 1 1 and onto, it is invertible. Okay, so options A and C are gone. Okay, options A and C are gone. And now we would like to see whether it is B or D. How will you find it? Tell me, how will you find it?
So we can find the like we broke it into two functions, one when x is greater than or equal to 0 and one when x is less than 0. So we can just find the inverse of each particular function and then check which one of these satisfies that.
Yes, that is one way to do it. Okay, so we can say that when x is greater than or equal to 0, y is also greater than or equal to 0, and y is equal to 3x. So x will be equal to y by 3. And when x is less than 0, y is also less than 0, and in fact y is equal to x. That. So x will also be equal to y. Okay. Now there could be some confusion here. Okay, there could be some confusion here. When we typically say that y is equal to f of x, we usually mean f inverse of y is equal to x. Okay, and then if you read options B and D, you realize that they are using x again as the variable for f inverse. But I think there is no need to get confused there. Why? Because what they have done is they have merely swapped the positions of x and y. So they have used f inverse of x instead of f inverse of y. So what you can do is, if you are not comfortable with f inverse of x because you have already used x as the original independent variable, you can go to these two options. You can go to these two options and delete x and put y there. Okay? You can delete x and put y there. Yes. Now tell me what you can do. Let's start with let us start with option D because it looks more convincing to me because of the 3 present in the denominator, right? Because of the 3 present in the denominator, and here it is y by 3 because no, in option B it is 1 upon 2, so it's hard to I'm not saying it's not right, but D looks more promising, so let's start with D. Okay, let us now go to values of y which are positive. So what will be f inverse of y? According to option D, f inverse of y will be negative y by 3 plus 2y by 3, that is y by 3. So that at least matches with this. Now let us go to negative values of y. Negative values of y, wherein f inverse of y will be, now mod y itself will be negative y. Negative of negative will be positive. That's why. Now does it match with this definition? It does. So option D is right. Is it clear?
Yes, sir.
Others, did you understand?
Yes, sir.
So we are substituting that y greater than equal to 0 in that additional equation.
No. What did you say? Y greater than 0?
So the additional equation that we have for the equal to mod x plus 2x by 3, that
No, I wrote these because from the graph I know that whenever x is positive, y is positive, and whenever x is negative, y is negative. Is that what you are
I
asking?
was saying, are we substituting the values of x and y in that additional equation? That we made it.
Oh, no, I still didn't get what you are what you are trying to say. See, okay, I'll explain what I did. First change that I made is I have replaced x by y in options B and D, but that is not changing anything, right? That is not changing anything. Whatever functions that you are describing there, they are still the same, only the variable that we are using is different, or the letter that we are using for the variable is different. Got it? Now I did that because here x is independent and y is dependent. So when you take the inverse like this, if this is f of x, this is f inverse of y. This is what I did. That's why I made the changes f inverse of y. Okay? Is that what you were asking or something else?
Yes, that was.
So in this case, I can still use y as f inverse of x. There is no issue with that. But now remember that my x is coming from the second set. Okay, and to avoid that confusion, I have kept it as y, and therefore I have changed x to y in options B and D. Okay. Now I have one more approach. If you find that convenient, you can opt for it. That second approach is picking up a value. Okay, picking up a value of x and then finding the value of y. Okay, look, what is our function? Our function is y equal to 3x when x is greater than or equal to 0, and y is equal to x when x is less than 0. So suppose I take x as 1. Okay, suppose I take x as 1, then what will be the value of y? My value of y will be 3. Now go to options B and D. Okay, go to options B and D and check which of the two options gives you 1 back if you substitute y as 3. If I go to B, okay, if I go to B, I should ideally have negative modulus of 3 plus 3 by 2. Okay, and what is that? That is negative 3 by 2, which is not equal to 1. Is that clear? But if you come to this, okay, if you come to this and then if you substitute y as 3, it will be negative mod 3 by 3 plus 2 into 3 by 3, that gives you 1. Got it? So again option D is correct. Yes? Did you understand this approach? Yes or no?
Yes, sir.
Okay, so any approach is better. I mean, whichever is convenient to you, can take it. See, it's not always the case for MCQs that you should always go with the analytical or the intended way of solving. If you have something else, some better approach, please go for it. Okay?